Hi, in this video, we're still working on topic 2.3. We're going to do explain 2. We're going to do the first part of the example before your turn in this video. So you can model real-world objects that have a parabolic shape using a quadratic function. In order to fit the function's graph to the shape of an object, you will need to determine the values of the parameters of the function. This is the function we've been working with the entire lesson, where f of x equals x squared. Note that because f of x is simply squaring a function, it's possible to pull a parameter b outside of the function and combine it with the parameter a. So basically they're saying here, we're not worrying about b, we're just going to use this function, okay? So when modeling real-world objects, remember to restrict the domain to the values of x that are based on the object's dimensions. So our domain will only be the object's dimensions. All right, so example 2 says we have an old stone bridge over a river, uses a parabolic arch for support. In the illustration shown, the unit of measurement for both axes is feet, and the vertex of the arch at this point is c. Find a quadratic function that models the arch and state the function's domain. Okay, so first of all, it's important to note that the shape of the arch is in fact a parabola. Okay. The vertex of the parabola would be this highest maximum point is 27, negative 5. The other 2 points on the parabola that we can see are negative 2, negative 20, and 52, negative 20. All right, so we're supposed to formulate a plan. Sometimes we do this part in our head. They're stepping it out for us in this one. So you want to find the values of the parameters a, h, k in this function here, where f of x equals x squared. You can use the coordinates of point C to find the values of h and k. Then you can use the coordinates of one of the other points to find the value of a. Okay, so we're going to do a lot of algebra we haven't done in a very long time. Okay, so I am going to start with the function g of x equals a times f of x minus and then I'm going to put my x value in here that I know for point C is 27. And then I'm going to put the k value in, which is negative 5. So this was just our generic formula that we had right here. Okay. And then I am going to take the value of one of my points. So I'm going to take that value right there and I'm going to plug it in. So this is going to go in for my x value. And I am going to be able to solve for a. So I'm plugging in g of 52. Remember, this is just notation saying g evaluated at 52 of a times f of 52 minus 27 minus 5. All right, I happen to know that the value, when I plug in the x, my y value for that g is negative 20. So I'm substituting that in for this. And then 52 minus 27 is 25 minus 5. Okay. I know that the function I am plugging into is x squared. So I'm going to do some work over here. So I know that I have to do f of 25 equals 25 squared, which happens to be 625. So that's what I'm going to substitute in for this. So I've got 20 equals a times 625 minus 5, which looks a little bit weird. So the next thing that I would probably do is I have to get a by itself. So I'm going to add the 5 to both sides. So I have 25 equals a times 625, and I'm going to divide both sides by 625. So I get 25 divided by 625 equals a. And then I know that 25 goes into both of those. I have a typo somewhere. This was a negative 20, wasn't it? So I was supposed to have negative 20, negative 20. It's going to be negative 15. Let's fix that up. This is supposed to be negative 15. Let's try that again. Good thing I didn't get too far. So negative 15, negative 15. Perfect. All right. Now, I know that 5 goes into both of those. 5 goes into 15 3 times and into 625 125 times. Okay? So basically what that means is I know that my function now is g of x equals negative 3 over 25 f of x minus 27 minus 5. Now, we're supposed to check our answer. This is kind of, for me, it's an up to you thing, but the book may force you to do it when you're doing the homework problems. I had 2 points, so I'm going to use this second point to plug in. Okay, so I'm going to do g of 2 is what I'm substituting in. So I'm substituting a 2 into this function. So g of 2 equals negative 3 over 25 f of, and I'm going to plug in the negative, or I'm going to plug in the 2, minus 27 minus 5. So we've got negative 3 over 25, 125. I have a typo there. Means I have to do f of negative 23. Is that right? F of, it was a 27. So negative 25 minus 5. So we know that our function is x squared. So I'm taking that 25 and squaring it. So negative 3 over 125 times 625 minus 5. I know 125 goes into 625 5 times. Negative 3 times 5 is negative 15. Minus 5 is negative 20. And what do you know? Wasn't that what our original point was up here? 2 negative 20. So it ended up checking out.